Hello, this is Jay, and this is the Busch Gardens analysis by Jay Hesnick and Chris Gaines. And so on the left here we have our acceleration versus time graph for the Griffin. So the blue series would be the x acceleration, the orange would be the y acceleration, and the gray would be the z acceleration. And so I just want to point out a couple of features on the graph. So from about 50 seconds to about 80, that is that's when you're climbing the first hill to gain the height needed to perform the rest of the roller coaster. And you will see how acceleration is constant through all of this because you're going up the hill at a constant acceleration. And so it levels out the graph makes and first hill acceleration bottom of the hill. Phone doesn't graph at the beginning. And the greatest angle is 90 degrees. Whoa, let's go back. Okay. And so the greatest acceleration is going to be, or greatest linear acceleration will be when it's 90 degrees. And then greatest overall will be when it's the bottom of the circle. So theoretical velocity. So we found this by using energy. So we know that energy is conserved because that is a basic law of physics. The height of the drop is 62 meters. And so we just said UGI equals KF. And after, canceling out mass, because mass doesn't matter, we found that the theoretical velocity at the bottom of the first hill would be 24.64 meters per second. So how fast were we actually going? And so this number we have right here is not all the way correct, and I'll explain why right now. So velocity, we calculated by using kinematics, and so we assumed, which was not because you have 9 points, you can probably assume by friction, which would make it final velocity less. It's acting on the increase in the total greatest on your velocity, and that's squared. So at the top of the first hill, and you just have gravitated because during the acceleration, it's always some logic. Sorry about this circle. Loop, you feel like your body, seat, friends and family, intriguing, or you feel it. And so you just think, oh, all these G different directions that's because we didn't stop or rise. And then you can see how it's constant, and that's because there's a constant information about, of course, that's just the acceleration down. And so negative 9.8 later, up, because it rides at, what you say, pretty much due to scare you, I guess, through would be because it's all kinetic up when it comes to a rest, and the acceleration, it's a greater acceleration to get you this object can be upward. The resistance graph as unless work is displayed because let's go back to energy. Work is down.